Okay, well, today I want to kind of realize and really show some examples of some of the themes Adam was talking about. This is really only partial. Oh, by the way, I'm Steve Hansen. I'm the Director of User Education here at LabKey. I really try to show people around the system, get them successful with it, and try to propose solutions for their problems. That's really my job here. I want to kind of pick up on Adam's themes and show you some just concrete examples of how LabKey does all that stuff that Adam was talking about. I'm going to do it inside of a really one feature set in LabKey, the LabKey Study module. This is a module that's really optimized to work with clinical data. And it's really the LabKey Study features are like an integration point for all kinds of different data that has different shapes, data that comes from different sources, etc. But I wanted to stress before I start out, this is just one feature set in LabKey. There's lots of others too. This is not just the end of LabKey. So I want to just again pick up on Adam's themes. I think I heard 5 in there. Working with diverse data, automating your data import, securing your data, working with large volumes of data, and integrating with other systems like external analytic systems. A little bit more before we get started into the details here. I wanted to say, just give you a little bit orientation around how LabKey Study module works, and why would you want to use it? What are the features supposed to do? Well, at the simplest level, most primitive level, the LabKey Study features help you assemble data in just a day-to-day quotidian sort of way. When you're doing a clinical trial or doing an observational study, there's a lot of data collection to handle. There's a lot of data coming from a lot of different directions, and you need to be able to assemble it and organize it, put it in the right place, in a central place. So that's kind of the simplest way to think about the study module, but it goes much deeper than that. It also gives you a lot of power around curating the data and running quality control checks on the data. You can say for a given piece of data, there's something wrong about this, or it needs to be reviewed. Or you can say it's past review. This is ready to be put into the analysis pipeline and be shown as our results. The study module also gives you a lot of power around mixing and combining your data. Once it's all inside of LabKey and applied, and the study module has been applied to it, the data really gels into one cube, if you like, one object that you can slice and dice and mix and show facets of, and really analyze in a really dynamic, powerful way. It also gives you the ability to just manage your cohorts and groups. When you're doing a clinical trial, you have different groups of participants that you want to compare performance on. You want to be able to compare the performance of the group that's the placebo group or the control group versus the group that got this treatment or that treatment. There's also lots of analysis and visual options for you when you're working with LabKey Studies. There's built-in analytics and statistics. We also make it really easy to use external analytic tools that Adam was talking about, like MATLAB and Stata, et cetera, are. Also, LabKey studies really have built-in concepts that it applies to your data as it comes in. Concepts like a subject or participant, a time point, a time slice, or a cohort. You can really sensitize the system to your data. And LabKey will parse that data with those concepts in mind and give you a pre-processed, pre-joined data set that's much easier to work with and really optimizes whatever analytics you're going to apply to it. Also, the study module is a stellar example of fine-grained security. You can apply security at all kinds of different levels in the study module, and I'll show you that as well. I mean, from a very crude level to a very refined level, down to the column level. It also helps you build audience-specific portals and presentation points, and can really help you support publications. If you're going to publish these results, we've had many clients who link back directly to the live data in LabKey, and it makes for a really powerful way to put your data out in the world. And finally, there are compliance controls that you can apply to your study data to handle those regulations, like HIPAA and FISMA, et cetera. Let's look at an example. We have a standard demonstration of a study portal. It's a kind of imaginary piece of research that I built out of my imagination, but it's really kind of inspired by real events in HIV research. This is it right here. It's our example HIV study. It is a portal that compares, it studies 12 subjects, and it compares different treatments for HIV, different antiretroviral treatments that they've received. And it puts it all together and tries to present something meaningful, something that you can make sense of. Here's my orientation page for this study. It gives you a little abstract. It gives you links into the most important parts of the study, such as the data sets we've collected and some of the key visualizations and analytics that we've done on it. Here's the raw data and the reports that I've built around this study, built around this effort. This page, I think, is a lot deeper than it appears. There are basically two things on this page. There's the raw data sets I collected. That's anything with a little grid icon here. And then there's the analytics that I've applied to this, to those raw data sets. Here, if I hover over these, you can see the visualizations themselves. This is my main result. It compares two different antiretroviral treatments, DRV and ETR. It's a little big here. And how folks have performed under those treatments over time. In particular, it measures their CD4 white cell blood counts under those two treatments. And this may not appear, the reason I say this page goes deeper than it appears, it may look to you like I've just got a list of data tables here. But it's more than that. Really, when LabKey ingests data sets into the study module, it parses them. It looks for those concepts I was talking about. It looks for subject IDs. And when it finds one, it isolates out all the data for that particular subject. Similarly, it looks for time point IDs. And when it sees that in the data, it creates a vertical time slice upon which it'll align any other data that it sees with the same visit ID. And it also essentially joins all this data under the covers. This may look like a bunch of different data sets, but it's not. They're really, if you like, one giant cube, one giant table under there, and I'm just showing you facets of it. By the way, here's a look at some of that parsing in action. Here's a list of the participants. I didn't make this list. LabKey made this list. It's part of its analytics of my data that as it came in. And if I drill into one of these participants, like participant 101, LabKey created this little data portrait for me. It's like a portrait of a single participant in the study, and it coalesced all the data in this one little place. Here's this person's demographic information. Here's their medical history. Here's their physical exam. These were all different tables that it pulled the data out of to build this little data presentation here. The data for this portal really came from lots of different sources. Some of it came from Excel files. Some of it came from a REDCap survey that I put online. Some of it could have come from, say, a pre-existing database that I informed LabKey of, and it sucked the data in, et cetera, et cetera. There are lots of different sources that LabKey can pull this data from. And it's also all has, different shapes. So, some of it is clinical. Some of it, a lot of the data comes in lots of different types. Some of it's clinical. Some of it's experimental and came out of the lab. Some of it's just surveys. Some of it's sample information. But once it's all here, again, it sort of gels, and you can analyze it with much greater efficiency. Just to give you a sense of that these two, take two of these grids that might appear different as two different data sets, like physical exam and demographics. Well, I can actually really easily pull columns between any of these data sets. So here I am on the physical exam data grid. Suppose I wanted to go grab some information from another table, another data set in my set. I can easily do that. I'm going to go into the plumbing that's underneath all of this. There's a little node here that lists all my other data sets. And if I wanted to just pull a column in from there, I can easily do it. Suppose I wanted to pull in the cohort column from this other data set. Sure enough, I now have a hybrid view, a hybrid grid from two different data sets. I have physical exam, but now I can see the cohort column and apply that as part of my analysis of this data grid. Another thing that I've done in this presentation in this data portal is I've added some ontology information here. I've imported the National Cancer Institute's ontology. Here it is right here. An ontology is really useful for controlling vocabulary. And it's also really useful for just adding metadata. Really, you're sort of adding metadata at scale when you're working with an ontology. It really brings in a huge group of data and really helps inform everything in your study. This right here is the big tree of all the concepts that are included in this National Cancer Institute ontology. And just to give you a sense of what it feels like, what's in this tree, let's search for something that's probably in here, aspirin. Well, sure enough, aspirin's mentioned all kinds of times in this ontology. Just the straight up plain aspirin here, but then there's also all these other ones, like an aspirin folic acid regimen, et cetera, et cetera. Well, let's just look at aspirin itself. You can see already there's a code for it. But the ontology also gives me a whole set of synonyms for aspirin. This is especially useful for controlling vocabulary. You know, when you're building a new study portal or a new research effort, there's often a lot of people entering a lot of data however they want to enter it. And that can create a lot of problems. Well, ontology can really help wrangle those kind of data input problems. Right here, this is the list that can really help data import people. You know, if they're from another country and they have like some other name for aspirin, did you know Emperin was a name for aspirin? I didn't know that. Or they enter Emperin or Ecotrin or something like that. LabKey's going to know what they're talking about. They're talking about aspirin. And you can actually see that right here. I'm just going to enter some data here. Imagine I'm filling out this medical history for the participants in my study. One of the labels here is their current medication. One of the columns here is their current medication. If I enter a new row of data here, I'm going to say this is for participant 101. If I enter Emperin here as their current medication, LabKey is going to interpret that, consult the ontology. I got to enter it. Here's what I just entered here, participant 002. And I entered Emperin, but LabKey said, well, you really mean aspirin, don't you? Now, it didn't throw away that Emperin value either. It actually holds on to that so that you really have both pieces of data, what was actually entered and how the ontology interpreted that, that piece of information as aspirin. Can you, by the way, Adam, can you see the Q&A section?
I can, yeah.
Okay, great. Any before I move on, any questions or anything you want to add?
One question I'll kind of paraphrase, but there's a question about assay data coming from an instrument. How exactly does that get in? Do I put assay data into a data set? How does that all work? So that, you know, to take advantage of the joining of columns and etc., like you showed.
Well, assay data, you know, LabKey has lots of different basic data structures available. There's data sets. Those are really designed for clinical data. There's assay designs. Those are really designed for experiments and assays. There's sample types. Those are designed for holding sample information, etc. Assay data is a little bit interesting in LabKey. I think you really have options for importing assay data. Sometimes you can import it directly as a data set, especially if it already has a participant ID column and a time point column. Or you could also import it as an assay design. And then we also provide, if you do it that way, we actually provide a way for you to move those assay designs into a study or into multiple studies. So I think you've got options there. They're not, you know, whether you import it directly as a data set or you import it kind of the long way as an assay, you know, it's really up to you. It's really kind of what you need. You know, both have their trade-offs. You know, assay, if we use an assay design, LabKey really respects and knows that you're kind of working with experimental data, and it'll give you lots of kind of features around that, like the ability to, you know, tie it to the original file, or divide and group your assays by runs of the instrument, things like that. If you import it directly as a data set, it's a little bit quicker, a little bit cleaner. So I hope that starts to answer that question. Anything else?
Yeah, on that question, I'll just throw out that one of the workflows that some of our clients use is to create a separate LabKey folder for different labs to use, and those labs will import assay data directly to those folders, and those folders are typically only visible to those lab members. And then at the time they are comfortable with the data, after they've done their QC steps and they've reviewed and they feel confident in their results, they can then copy to study, meaning they will basically create what's called an assay data set from the assay. So in some ways, it's the best of both worlds. So the assay still resides in a separate folder, but then a sort of a data set version of that assay will appear in the study and can be joined and linked and queried, et cetera, the same as any other data sets.
Yeah.
And just as a little spoiler alert, we are working on the same thing for sample types.
Yeah. So
sample types will have the ability in our next release, 21.7, to essentially copy to study, or really we call it link to study from a sample type, so that samples that are participating in a particular clinical trial can be linked to that trial with essentially a sample data set in the same manner. So we're using that same model for sample types.
Yeah. Great,
and then since we're in the Q&A portion here,
sure.
We had another question that came in through chat. When you create new views of translated data, whether that is by lookup or ontology, can you choose, or how can you choose which value is shared in a view or report?
Now, I assume you mean you're talking about maybe the ontology side of things,
yeah, I would think it's probably the the data set where you had that here, but maybe you can show the other columns.
Yeah, I've actually hidden something here, which I'll show. Notice I have a field. I'm going to add a field called the current medication import.
I would add the current medication. Well,
let's add them both. Let's add them all.
These are all the pieces.
There's actually kind of three facets of this data. The ontology really gives you three facets. I was just showing one, but here, let's just turn them all on. If you remember, I entered that value, empirin. LabKey knows I meant aspirin, and it knows the NCI code. I just hid all that because it's kind of messy. So great. Any other?
Some people like those codes, but
yeah, sure.
Yeah. So what's going on there is that as you can see, the import value is maintained, and then LabKey will look at both effectively the canonical name or preferred name, as well as any of those synonyms, right? Like Steve showed the synonyms for aspirin. And if there's a match in any of those things, LabKey will then fill in the current medication with the actual code, right? Because ultimately the code is really the main thing here. But then we will also fill in the label, meaning the canonical name for this particular concept. So you have the option in any view and any report to show any of those. If you really want to see the concept codes, you can see those. If you just want to see the label, you can show those, or you can show both. It's it's really up to you. And then of course, you have the ability to save views like this, and you can save them as private views, or you can save them as shared views that anyone can see. If you have the right permission, if you have the appropriate permission, you can make views available to to everybody who comes to this particular folder.
Yeah, you can see I've kind of tweaked the view a little bit, the grid a little bit, and LabKey can see that and say, do you want to save this? And so it's asking me to. I'm going to say no. Now, anything else there?
Yeah, actually, there's one more. What about electronic case report form, ECRF? Can LabKey be used to collect data as an ECRF?
If REDCap, I actually don't know if REDCap is what you mean, but if it is, that's coming up in a minute.
Yeah, I think you'll be putting REDCap as one example, and then just so folks know, we also support metadata rave and DATSPAT. So we support a number of different ECRF systems.
So let's move to that. I think this is Adam's second theme, was automated data import. Again, there's lots of ways to do this in LabKey. I just have two ways I want to show you here. One is REDCap. We support integration with REDCap. REDCap, by the way, is a popular survey, online survey mechanism or electronic data capture tool that allows you to, it's in many ways similar in spirit to LabKey, allows you to define data sets and tables that people can fill in online. Patients can even directly enter data into them in sort of a survey style. Well, LabKey can actually hook up to one of your, if you have a REDCap installation, LabKey can hook up to it and ingest data from it. Here is a REDCap survey that I built. It's has 2 participants in it right now, and it asks them, it collects data over these various visit points or time points. There's an enrollment, there's 3 doses and 3 follow-up visits in this REDCap instance. I pointed LabKey at this and I told it about it, and I said, LabKey, I want you to import that data. So here's another study portal, which is in a much less developed state than what we just saw. This is sort of a brand new portal I'm trying to build out. It just has 1 data set in it. But suppose I wanted to go get that REDCap data. I have a little button here that will do it. And LabKey will all of a sudden grab that data. I now have all of those data sets to work with. And you can see the shape is really similar. I mean, LabKey knows about those vertical time slices in the data, and it knows about the visits and the doses now. And we're ready to start analyzing that REDCap data. By the way, I think, Adam, we actually do support CDISCs. I think CDISC and REDCap are very similar. And when I looked at the docs just now, I think we do support CDISC. So a correction out there, somebody that's take a look at that.
This import takes place over, I think it's ODM. So yes, the import is taking place over CDISC. We don't currently export in that format.
Oh, okay, I hear you. Great. Okay.
I think was his question. Hey, Steve, just one quick thing. If you close that download bar and the background,
sure,
that will just give you a little more.
Great, thank you.
Folks, a little more real estate.
Super. Any questions? Keep going?
No new questions.
Okay, great. Another great mechanism for this kind of automated pipeline is to build a file watcher. And file watchers are like little agents that you can point at a directory. And this little agent will watch for files. It'll listen for files in that directory. If it sees anything, detects some new file or an updated file, you can then ingest it, and you can ingest it in all kinds of different ways. You can create a data set from it. You can create a list from it. you can just move the file to some other location on the server, things like that. And I've configured one of these little agents here. Here's a another portal that I'm going to download some files here. In this portal, it's designed to detect files in this directory right here. Here's my file portal or file window. And anytime I drag files into this, you can see they kind of drop into this black hole and they're gone. Well, they got processed. What happened is LabKey, the file watcher I've imported here, saw them and moved them somewhere else and imported them into a study. Where did it move them? It moved them into study A. Yet another study portal. Notice there are those 3 data sets I just dragged into the file watcher. It imported the data and I'm ready to go with it. It's even, is a fairly deluxe file watcher. Notice the files I imported are named, have a little naming pattern here. There was study A underscore demographics. Well, what that told the file watcher was, this is, the first part says study A. It says, oh, this goes into study A. If I had done study B, it would have gone into another place, study B. And that's just a little trick I added to the file watcher. And then the second part of the name is just the name of the data set I want to use in the actual study. So that's a great example of just a wonderful automated pipeline you can build. I didn't need to use any code or anything to do any of this stuff. Actually, it's all just built in with a really easy user interface. Questions there, or anything we should add, Adam?
Yeah, there's when these files have updated data, where do we see any errors during the uploads?
Yeah, let's take a look. First place I would look is the data pipeline module. These are all handled by the pipeline. And let's see. Here is where I would look for those errors. Of course, mine are all complete and without errors, but I've done this 141 times. I bet there's an error in there somewhere.
Practicing.
Oh, no, I'm perfect. I'm perfect. There are no errors, but imagine that there was. Yeah, you know what? Here, let's break it. I'll show you. I'll show you how.
There are.
Yeah.
Okay. Yeah, it's good to point out that pipeline was showing the copy or move step. I guess move in your case, and then in the destinations.
Oh, let's go. That's a great point. Let's go to the destination. And let's look at the pipeline.
So there are kind of 2 steps that his file watcher did. I mean, he said this, but just to make it clear. Step 1 was moving the file to the study folder. And then step 2 was actually importing that data set into that study. So now we're seeing the data pipeline for, for the case where it was actually imported. And so if there were actual import errors, they would show up in that pipeline.
That's right. That's right. Well, actually, we're a little bit short on time. I want to keep going here. But I don't have an actual error to show you, but that's where they would show up if you have any. Any other questions out there, Adam?
Yeah, there's just a question about what edition the file watcher is available in.
Oh, it's been available for a few years now.
But which actual edition?
Oh, it is, I believe, in the professional edition. It's not a community feature. That's right. Okay, great. Well, let's move on. Another theme that Adam touched on was security. And I think there's so many security features in the study module. It's more than I can even talk about, but I think two aspects of it are important. First of all, there's just lots of different levels at which you can apply security in the study module. At the crudest level, there's just the portal level itself. You can say, I want to show this portal to you, but not to you, or not to anyone. So the whole portal can be either revealed or concealed. You can also do the same at a finer grain of a finer level of granularity. You can do it at the data set level. So I can say for a given portal, for a given data set list here, I can show or reveal any of these. You can also do it per report. So any analysis that you've done, like these up here, I can show or reveal as I see fit to whichever audience I see fit. And finally, even at the column level, you can show or reveal individual columns within a data set. You can also apply, and that's even before you worry about compliance controls. You can also bring in the compliance features to further refine your security configurations. So you can do things like data de-identification. You can say, you can, for instance, say, I want to scramble the dates, the real dates in my study. I want to instead shift the dates so that I'm not showing real dates to the world. You'll retain the real dates in your data, but on display, you'll see that they're fictional. You can also scramble the participant IDs so that you're not showing the real participant IDs, but some other version of them. We also provide special handling for columns that you mark as PHI columns. And you can require that viewers and editors of those columns have particular security roles enabled in order to go and see those or interact with those columns. The compliance features also provide intensive logging of the activity around the data. In particular, this logging tries to answer this question: who saw what and why? Who saw what and by whose authority? You really want to be able to answer that question, say for patients who want to know. That's part of their prerogative. And you can also require that data viewers sign a terms of use before they enter the portal and start looking around. There's lots more to say here, but again, any questions? And Adam, I mean, you wrote the compliance module, so anything you want to add here?
No, I think you covered it. I'll just say that give a little plug to the documentation writers. The docs for this area, the area of security, are quite comprehensive and worth a look. There, like Steve says, there's a lot here, right? I mean, particularly study security, the per data set, per column kind of capabilities are worth understanding in detail. That allows you, and I mean, it's worth, I guess, saying, this is how you implement, for instance, cohort blinding or hiding data sets or making them available to select segments of your constituents. And of course, the per column compliance features allows you fine grained control, particularly for identifiable or potentially identifiable information. So whether it's zip codes or other more specific identifiers, you can choose the level at which you basically choose who gets to see each and every piece of data using security groups. We did have a couple of questions. So let's see, just reading these on the fly. If we scramble participant IDs, can they be linked back by admins? Just thinking of this, if I share data via portal and my collaborator wants to select participants of interest and I don't want to initially share real IDs, and the short answer there is yes.
Yes.
So LabKey, so the scrambled participant IDs, you have control over kind of the format of those, but we'll, effectively kind of tack on just a randomly generated ID. It's randomly generated, but LabKey will save that away as a part of the study. And so if you publish multiple times or you export multiple times, we will use the same identifier every time, unless an administrator explicitly goes and says, I want to clear those out and start over again. But as long as you don't do that, we will save all those IDs and reuse them. And you do, as an administrator, and only the administrators have the ability to export that mapping so that they know they can, do the reverse mapping if they need to. Only administrators can see that, nobody else.
Yeah.
And then there's a question, when using schema browser and loading views from SQL Server, is there a way to combine these views as loaded in LabKey without using R or other analysis tool to create combined views and simple analysis as you've shown?
Absolutely, really. That's not even a problem. Honestly, when LabKey is, first of all, very democratic about the databases it can pull from. It can pull from Postgres, SQL Server, Oracle, MySQL, and others. And by the time it gets to the study module, LabKey doesn't even distinguish between the different databases. They're all just interanalyzable, and there's really an abstraction layer in LabKey around the databases. You don't even know what database it came from, sort of as a data analyst. It's just there available to be worked on.
And then I'll add to that. The question was about combining these views, which is maybe a little ambiguous. Certainly you can combine them in a variety of different ways without any kind of code. If, for instance, you have, I'm not sure if this is the exact scenario, but let's say your main database is Postgres and you have other data residing in a separate SQL Server database. You want to bring that data into the study. You can certainly use this feature we call external schemas or external data sources to bring that data into that same folder. You can do a variety of different things with it. All the usual data analysis features are available to it. And then if you literally want to join that data with the rest of the study, that's where we would typically recommend, or at least one option would be using an ETL. To pull that data into, and you can set it up to be scheduled on a regular basis, so that it pulls it in regularly. But basically that way you can essentially replicate that data or synchronize that data with a data set in the study. And then it's a data set just like any other data set that you can go into and do everything else with. So that's a frequent pattern that.
Yeah. Great. Anything else?
Nope, I think that's
going a little bit over here.
Good.
As for working with large data sets, I'm going to kind of leave this to the viewers out there to kind of look into some of the projects which have used large data sets. I think of the 100,000 Genomes Project. They have great resources, by the way, to just look at and see how they pulled that off. IT and TrialShare, another public website you can look at, another LabKey instance that's out there in the world. And also primate research centers often use LabKey to handle large sets of legacy data, 30 years of colony collection data. But I'll keep moving to the kind of my final theme here, which is analytic tools. I've really listed here just a few of the external analytic tools that LabKey can work with. I'm not even talking about the internal analytic tools that we provide, the API tools that we provide. Just to round it out, let's show you some work that I've done in Tableau on our HIV study. This is a instance of Tableau, Tableau desktop, that I pointed at my imaginary HIV study. And I just played around with Tableau, just kind of taught myself Tableau and created these beautiful visualizations. You can do very similar things with our studio. Just quickly point our studio at a LabKey server. It can see the data and you can start working with it. This was really easy to set up. And if you're a Tableau fan, you're going to have a great time.